This is David Flores, and I am in section 010. This is the problem we're doing. So what is the value of the equilibrium constant K for a reaction for which delta G is equal to 4.80 kg over mole at 50 degrees Celsius? So first we're gonna see what our givens are. We have 4.80 kg over mole. We have 50 degrees Celsius. And then we're gonna use our constant of 8.314 since we're working with joules over mole times K. So I'm just gonna write that here. Okay, and just based on what I have, I can just tell that I'm gonna use this equation, which is delta G equals negative RT ln K. Right. Then, before I start like plugging stuff into my equation, I have to change some things. First, for the 4.80, I have to turn this into joules. So I'm gonna do that first. 4.80 kg times, and then we know that in 1 kg or a kjoule in this scenario, we have 1,000 joules times over 1, we have 1,800 joules. Perfect. And then we also have to change this into Kelvin. So we would just add 50 plus 273 Kelvin, and that would give me 323. All right, and then now we just have to adjust this equation. So we will do ln K equals to negative delta G over constant and then temperature. And from here, we just plug in the numbers we have. So we would do ln K equals negative 4,800 joules, which is from this equation, from this unit. And then we will do our constant, which is 8.314. And then our temperature, which we got, which was 323 Kelvin. Now, we plug this into a calculator. So we do negative 4,800, 8.314, 323. All right, so we get ln K equals negative 1.78742858, and we don't want to round yet, so we just put the whole big number. And then in order to cancel out the ln, we do the e to exponentiate it, and so we do whatever we do this side, we do to the other. So we do K equals to e to the power of negative 1.78742858. We put in the calculator. Oh, wait. Negative 1.78742858. All right, and then we get an answer of K of 0.167, and we just leave it here because the question asked us for 3 sig figs. So your answer will be 0.167.